Imagine a rocket,
Hmm.
right? It's sitting on an ISRO launch pad down in Sriharikota.
Right, getting ready to go.
Exactly.
Duh.
And the ambient temperature there is sweltering. The humidity is super thick. You can see these intense plumes of white vapor just venting off the side of the launch vehicle into the air.
Yeah, it's a very dramatic visual.
It really is.
Yeah.
So hold that image for a second and transport your mind halfway across the world to a fusion reactor in southern France, the ITER project.
Oh, wow. Yeah, that's a whole different scale.
Right. Here you have scientists attempting to basically replicate the power of the sun inside a magnetic cage. They're containing plasma that reaches like 150 million degrees Celsius.
Which is just, I mean, it's hard to even wrap your head around that kind of heat.
It is. And then finally, bring your focus back to the global shift toward clean energy. So think about fleets of commercial trucks running on liquefied natural gas or entire industrial sectors pivoting to green hydrogen.
Right, which we're seeing everywhere now.
Exactly. So you might be asking, what on earth do these three things have in common?
Well, the common thread connecting a space launch, a synthetic sun, and the whole green energy transition is, ironically, the necessity to tame the extreme cold, like physics-defying cold.
It's wild to think about. To harness the highest energy technologies we have, you have to first master environments that hover just above absolute zero.
You really do. I mean, you're dealing with volatile elements that, if they aren't managed perfectly, can cause materials to just shatter like glass or, trigger catastrophic explosions.
Which brings us to our topic today. Welcome to today's deep dive. We are looking at a stack of research, market reports, and financial documents on a company called INOX India Limited, or INOX India.
Yeah, a really fascinating company.
And our mission today is to unpack how a completely behind-the-scenes engineering firm from India became this dominant player in the global cryogenic infrastructure transition.
Because mastering the cold really is the absolute linchpin for all these hot industries of tomorrow. Space exploration, semiconductor manufacturing, green hydrogen, all of it.
Right. And you rarely hear about the companies actually building the storage infrastructure. I mean, the focus is always on the fuel itself,
Right.
right? Like the thrust of the rocket or the processing power of the microchip.
Exactly. But none of that operates without the highly engineered vacuum-sealed containment systems. You need those to keep these volatile elements stable until the exact moment they are needed.
So this is a story about the invisible backbone of the future economy. We're going to look at the physical hardware they build, the global demand driving their growth, the incredibly high barriers to entry in this sector, and of course, the financial engine underneath it all.
Because that thermal plumbing is where the real bottlenecks are, and also where the critical opportunities lie.
Exactly. The goal is that the next time you hear about a green energy breakthrough, your first thought will be about the thermal plumbing that actually makes it possible.
Let's hope so.
So before we get into the global market dynamics, we need to establish a baseline for the hardware. We are talking about cryogenic engineering here. INOX India is India's largest cryogenic engineering company, and they've actually been operating since 1976.
Right, they have a lot of history.
Yeah. And the core of their business is designing and manufacturing these double-walled, vacuum-insulated equipment pieces for storing and transporting gases at extremely low temperatures.
Which is much harder than it sounds.
Right. I mean, I have a general sense of how a standard consumer thermos works, but looking at these sources, this is a completely different league of engineering.
Oh, completely. The scale and the stakes are entirely different. When we talk about extremely low temperatures in cryogenics, we were referring to liquid nitrogen at like minus 996 degrees Celsius.
This is incredibly cold.
Or liquid hydrogen at minus 253 degrees Celsius.
Mm-hmm.
And at these temperatures, the normal laws of physics start to work against standard materials.
How so?
Well, if you try to store liquid hydrogen in a standard carbon steel tank, the steel undergoes what's called a ductile to brittle transition.
Wait, what transition?
Ductile to brittle. So the crystalline structure of the metal essentially locks up, it becomes brittle, and just a slight bump or vibration will cause that steel to shatter into pieces.
Wow. So standard steel is just totally out of the question. The metallurgy has to change completely then.
Exactly. You have to use specialized austenitic stainless steel, or specific nickel-based alloys.
Right, I saw that in the notes.
Yeah, these metals have a face-centered cubic crystal structure, and that means they remain ductile and tough even when subjected to temperatures near absolute zero.
Okay, so that solves the metal shattering problem.
Right, but the metallurgy is only half the battle. The insulation is where the true complexity lies. So the tank has an inner vessel holding the liquid and then an outer vessel, and between them is a vacuum space.
Okay, so if I think about a high-end camping cooler, right, like a Yeti cooler. It uses a vacuum to keep ice from melting, because heat needs a physical bridge like air molecules bumping into each other to travel.
Exactly.
So if you remove the air and create a vacuum, you eliminate conductive and convective heat transfer. The heat from the outside simply has no medium to cross over to the inside.
That is the foundation of it, yes. But a vacuum alone does not stop radiant heat.
Radiant heat.
Yeah, electromagnetic waves that can cross empty space, like how you feel the heat of the sun. So to combat this, INOX fills that vacuum space with multi-layer insulation.
Oh, interesting. What kind of insulation?
It often consists of alternating layers of reflective materials and spacer materials. The goal is to bounce that radiant heat back outward. Because if any heat at all breaches that barrier, the liquid inside begins to boil and turn back into a gas.
And I imagine that's bad news in a sealed tank.
Very bad. When liquid hydrogen turns into a gas, it expands to over 800 times its liquid volume.
Wait, 800 times? It's enormous.
Yeah, so if the container is not engineered to handle that immense sudden pressure spike, the tank will just rupture violently.
Wow. So if a camping cooler fails, your drinks get warm. But if a cryogenic storage system fails at an industrial site,
A hospital loses its life-saving oxygen supply. Or a space launch is scrubbed. Or an industrial facility faces a catastrophic explosion.
the stakes are just absolute.
They really are. And INOX is building equipment across a vast spectrum of sizes to handle these stakes.
Right. The sources show they manufacture everything from small, 1-liter portable dewars, which are used in medical settings for storing biological samples or vaccines.
Yeah, the really small stuff.
And then they scale all the way up to stationary storage tanks holding 1.5 million liters of liquefied gas for these huge industrial hubs.
The scale difference is pretty staggering.
It is. And looking at the logistics of moving these materials, the sources highlight a specific project that really puts the engineering into perspective.
Oh, the ISRO tank.
Yes. INOX built a 40,000-liter liquid hydrogen transport tank for ISRO. And this tank had to safely transport liquid hydrogen across a 700-kilometer route to the launch pad.
Which is no small feat in India.
Exactly. You have ambient Indian summer temperatures outside the tank, potentially reaching like 40 degrees Celsius, and minus 253 degrees Celsius inside.
Separated by just a few inches of vacuum and steel.
Right. And they're bouncing over uneven roads, dealing with constant harmonic vibrations from the truck for 700 kilometers.
The structural engineering required for a transport tank like that is uniquely demanding, because you also have to account for slosh dynamics.
Slosh dynamics,
Yeah.
like the liquid moving around.
Exactly. 40,000 liters of a highly volatile liquid moving back and forth inside a tank creates immense kinetic energy. So the interior has to be fitted with complex baffle systems to prevent the liquid from shifting violently and destabilizing the truck.
Oh, so the truck doesn't tip over.
Right, but you have to do that all while ensuring those internal structures do not create thermal bridges that allow heat to leak into the inner vessel.
That is just an incredibly tight engineering needle to thread.
It really is.
So looking at the revenue breakdown, they divide their operations into 3 core verticals. Industrial gas systems make up about 60% of their revenue.
The biggest chunk.
Yeah. And then LNG, or liquefied natural gas, accounts for about 28%.
Right.
And the third is a niche segment called cryoscientific solutions. Now, within these verticals, they have standardized products. These are items like beverage kegs or disposable refrigerant cylinders that sell for roughly 800 to 1,200 rupees per cylinder.
Pretty standard commercial stuff.
Yeah, and standard storage tanks might sell for maybe 15 to 25 lakh rupees, but the standardized equipment is actually a very small part of the financial picture.
Yeah, over 90% of their revenue is generated from engineered-to-order turnkey systems.
Right, so they operate much more like specialized thermal architects than a traditional assembly line manufacturer.
Exactly. When you move away from the standard tanks and look at custom high-pressure tanks built for specific volatile gases, the price jumps significantly. You're looking at 30 to 50+ lakh rupees.
And the cryoscientific systems go even higher, right?
Yeah, those can reach 40 to 70+ lakh rupees. I mean, if an industrial client needs a liquid natural gas satellite station, they don't just buy a tank.
What else do they need?
They need the storage vessel, the cryogenic piping, the vaporizers to convert the liquid back into a usable gas, and all the pressure regulation skids.
Oh, so it's a whole ecosystem.
Right. And INOX provides the entire turnkey solution, designing, manufacturing, installing, and commissioning the complete system.
You know, it's funny. When the government announces funding for green energy infrastructure, the visual that usually comes to mind is a field of solar panels or a row of offshore wind turbines.
Yeah, the visible generation side.
Exactly. But the generation of energy is only step one. Storing and moving that energy safely requires these exact, engineered-to-order, vacuum-sealed cryogenic systems.
You can produce all the green hydrogen imaginable, but without the thermal containment hardware, the energy just cannot be deployed into the economy.
Liquid gas storage really is the physical bridge between energy generation and energy consumption.
It is. The ability to compress and hold volatile gases safely is truly the limiting factor for how fast these new energy economies can scale.
That perfectly brings us to the global demand and who is actually buying these systems. We need to look at the total addressable market, specifically the Indian TAM.
Which is growing incredibly fast.
Yeah, the sources say the Indian cryogenic equipment market is currently estimated at around $1.8 billion for the year 2026.
Right.
But the projections suggest it's going to reach roughly $4.86 billion by 2033, which represents a compound annual growth rate of 8.3%.
That's a very steep curve.
It is. And to understand why India is driving this specific 8.3% growth curve, the research points to a concept called the penetration gap. Can you break that down?
Sure. So India's industrial and energy sectors are severely underpenetrated when it comes to cryogenic applications, especially when you compare it to global averages.
What's the most obvious example of that?
The most glaring example is LNG as a share of total fuel consumption. In India, LNG currently makes up only about 5 to 6% of the fuel mix.
Okay, and what is the global average?
The global average sits between 20 and 25%.
Oh, wow, that is a huge gap.
It is. So for India to just align with the global average, the underlying physical infrastructure for importing, storing, and distributing all that liquefied natural gas has to undergo an exponential expansion.
And it's a similar story with industrial gas intensity, right?
Exactly.
This measures the amount of gases like nitrogen, oxygen, and argon used in manufacturing on a per capita basis. And in India, that intensity is valued at roughly $30 to $40 per capita.
Right. And if you look at the United States or Europe,
It's between $120 and $150 per capita.
exactly. So as Indian manufacturing continues to formalize, as it scales up and moves into higher value production, the consumption of industrial gases naturally rises.
Because you just need more of it for advanced manufacturing.
Right. You just cannot operate large-scale steel manufacturing, chemical processing, or advanced fabrication without a continuous, high-volume supply of nitrogen and oxygen.
Which means they need tanks to store it all.
Exactly. Closing that per capita gap requires a vast rollout of stationary cryogenic storage tanks at manufacturing sites all across the country.
So the sources outline a few specific structural drivers that are really propelling this demand. First is the LNG transition. The Indian government has set a target to achieve over 150 million tons per annum of LNG import capacity by 2030.
That's a very aggressive target.
It is. And alongside those import terminals, they are expanding the city gas distribution network to over 500 cities.
And that city gas distribution requires an extensive web of cryogenic infrastructure.
How does that work in practice?
Well, to pipe cooking gas into millions of residential homes, you have to establish hundreds of local satellite stations. These stations receive the liquefied natural gas from transport trucks. Then they store it in cryogenic tanks and then use ambient air vaporizers to warm the liquid until it expands back into a gas. Then they regulate the pressure before it is fed into the local pipeline network.
Oh, I see. So every single new city added to the grid requires multiple installations of this specialized hardware.
Exactly. It's a huge undertaking.
Another major catalyst, the sources point out, is the semiconductor sector. India has initiated a $10 billion policy push to establish domestic chip fabrication plants.
Right, the PLI scheme.
Yeah. And semiconductor fabs are highly sensitive environments, and their reliance on cryogenic engineering is absolute.
It really is. The manufacturing of silicon wafers involves processes like photolithography and chemical vapor deposition.
Which sounds incredibly complex.
It is. These processes use specialized excimer lasers and highly reactive chemicals that require the delivery of ultra-pure gases, things like argon, nitrogen, and fluorine.
And how pure does it need to be?
The purity requirements are often measured in parts per billion, or sometimes even parts per trillion.
Parts per trillion.
Yes. If a delivery pipe has a microscopic internal flaw, or if a storage tank allows even a minor temperature fluctuation that introduces a contaminant,
What happens?
a single speck of impurity can ruin a wafer worth tens of thousands of dollars.
Wow.
So cryogenic handling systems are really the only way to ensure the gases remain perfectly stable and pure from the storage tank all the way to the factory floor.
That makes total sense. Then there is the National Green Hydrogen Mission. They're targeting the production of 5 million tons per annum by 2030.
Hydrogen is notoriously difficult to store.
Right, because it's the lightest element in the universe. And the sources say its molecules are so small they can actually permeate the structure of standard steel.
Yeah, it causes a phenomenon called hydrogen embrittlement.
So storing 5 million tons of it is going to require an entirely new architecture of advanced cryogenic infrastructure. And finally, the healthcare sector is a steady driver here. Upgrading hospital bed capacity nationwide basically necessitates the installation of vast, reliable cryogenic oxygen networks to ensure uninterrupted medical supply.
Right, so you can see the demand profile is really split into two categories, commercial and policy-led.
Right.
Commercial demand, which is driven by sectors like food freezing, pharmaceutical storage, and basic metal fabrication, provides steady, predictable growth.
Makes sense.
But then you have policy-led demand. The government targets for LNG import capacity, green hydrogen hubs, semiconductor fabs. That creates a structural runway.
How long is that runway?
These policy initiatives require 10 to 15 years to fully implement, so that provides a highly durable window of growth for the companies supplying the foundational hardware.
Okay, but I have to push back a bit here. You are citing 2030 government targets for things like hydrogen and LNG.
Right.
Policy mandates often look great on paper, but the timeline between a politician announcing a target and a company actually pouring concrete can be vast.
That's a fair point.
Right, so we need to distinguish how much of this demand represents actual steel going into the ground today, as opposed to just future projections or wishful thinking.
Well, the city gas distribution networks and the hospital oxygen upgrades are active, ongoing projects right now. The orders are physically flowing through the system today.
Okay, so that's immediate.
Yeah. INOX currently commands a 60 to 70% market share in the Indian LNG infrastructure equipment space. And they are actively executing those turnkey projects to meet the current expansion of the city gas grid.
And what about the semiconductor stuff?
The semiconductor fabs are breaking ground now. They are initiating the procurement cycles for their gas handling systems as we speak.
So the hydrogen targets might be a bit more forward-looking, but the LNG and healthcare infrastructure is immediate.
Exactly. And the critical factor to remember is that these are capital-intensive, long life-cycle assets.
What do you mean?
An industrial gas major or a city municipality is not purchasing a storage tank for a temporary 6-month project. They are integrating an asset designed to operate for 20 to 30 years.
I see.
So government timelines might shift slightly, sure. But the infrastructure gap is a physical reality. The economy simply cannot increase its manufacturing output without the industrial gas storage to support it. The trajectory of the demand is firmly locked in.
Okay, that makes sense. So we have established a captive market growing at an 8.3% CAGR with billions of dollars allocated for infrastructure.
Yes.
Now, in a typical industrial sector, a growth curve like that would invite hundreds of new competitors, right?
You'd think so, yeah.
Local steel fabricators would just retool their factories and start welding tanks to capture a piece of that $4.86 billion market. Yet INOX maintains a domestic market share of over 60%.
It's remarkably concentrated.
It is. We really need to examine what exactly keeps new competitors locked out of this space.
Well, the barrier to entry in cryogenic engineering is honestly one of the deepest competitive moats in the entire industrial landscape. Yeah. Looking at the competitive field, INOX dominates the Indian market, and their primary domestic competition is really just Linde India, which is a subsidiary of the global giant Linde PLC.
And globally.
On a global scale, where INOX holds roughly a 1% market share, they compete against entrenched titans like Chart Industries based in the US, Air Liquide from France, and prominent Chinese manufacturers like CIMC Enric.
But a local Indian steel fabricator simply cannot enter this market. And the sources say it's because of the certification moat.
Yes, the certification moat is huge.
The volatility of the gases involved means the safety standards are regulated at a microscopic level.
Quite literally microscopic.
Yeah, the sources list an extensive array of certifications INOX has acquired. They have ASME Section 8, the PED certification for the European market, CRN for Canada, various ISO standards.
Right.
They're also the first Indian company to achieve IATF 1S16949, and the only Asian keg manufacturer with FSSC 22000.
Which is a very big deal. These certifications are not merely administrative stamps you just pay a fee for.
No.
Not at all. They require grueling, multi-year audits of a company's engineering and manufacturing capabilities.
Can you give an example?
Take ASME Section 8, which governs boiler and pressure vessel construction. When a company builds a high-pressure cryogenic tank, every single weld must be subjected to non-destructive testing.
What does that entail?
This involves radiography or X-raying the welds to check for microscopic internal voids. They use ultrasonic testing and dye-penetrant inspections.
Wow, so they are inspecting the inside of the weld itself.
Exactly, and then the tanks are hydrostatically tested.
What's that?
That means they are filled with water and pressurized far beyond their intended operating limits, just to empirically prove they will not rupture.
That sounds intense. And what about that automotive certification?
Yeah.
IETF 16949.
Right, that one is mandatory for automotive cryogenic tanks. If you are building an LNG fuel tank for a commercial truck, that tank has to endure the constant harmonic vibrations of a heavy-duty diesel engine.
Right, because it's literally attached to the truck.
Exactly. It has to handle the impact of potholed roads and potential collision forces, all without leaking a highly flammable liquid.
That's terrifying to think about, honestly. And the FSSC 22000.
That's for food safety. So for beverage kegs, it requires the use of food-grade stainless steel engineered with zero microscopic crevices where bacteria could potentially breed.
Ah, I see.
So achieving and maintaining all these certifications requires flawless execution and specialized testing facilities that a standard metal fabricator simply does not possess.
That makes total sense.
Yeah.
Furthermore, regulatory approval is only the first hurdle, right?
Yes.
The sources mention that the customers themselves impose equally stringent barriers.
Oh, absolutely. If a supplier wants to sell equipment to an industrial gas major like Air Liquide or to an EPC, an engineering, procurement, and construction contractor, they must navigate internal vendor qualification cycles.
In internal cycles.
Yeah. These cycles involve years of safety testing, performance auditing, and pilot projects before a vendor is even approved for large-scale procurement.
So this dynamic creates incredibly high switching costs.
Yes.
Like, consider an EPC contractor tasked with building a $500 million LNG import terminal. They have a strict budget and a rigid completion timeline.
Right.
The contractor is not going to risk the safety of the entire facility, the lives of the on-site workers, and the liability of a delayed commissioning just to buy a storage tank from a new uncertified vendor to save a few lakh rupees on the upfront cost.
They would never do that. The risk of a catastrophic failure far outweighs any marginal cost savings.
Exactly.
I mean, if an uncertified tank fails a pressure inspection during the commissioning phase, the entire multi-million-dollar project is halted.
Right. So once you're in, you're locked in. The switching costs are just brutal.
Precisely. Once a supplier like INOX has completed the qualification cycles and is integrated into an EPC supply chain, they are highly insulated from new entrants. Uncertified vendors cannot guarantee the structural integrity required. And in the cryogenic industry, the guarantee of safety is the core product being sold.
And the sources indicate this moat is actively strengthening.
It is.
Because as INOX expands into even higher risk sectors, like the semiconductor fabs requiring parts per trillion gas purity or liquid air energy storage systems, the tolerance for error drops to absolute zero.
Yeah, the stakes just keep getting higher.
The more complex the technological application, the more valuable a decades-long track record of certified safety becomes.
Exactly. They are continuously engineering customized, high-stakes thermal solutions that smaller fabricators just lack the beta models and testing infrastructure to even attempt. So it creates this self-reinforcing cycle. Their expertise allows them to win complex projects, which in turn deepens their engineering capabilities and strengthens their competitive advantage.
But there is a significant threat in the market that challenges this moat, right?
What's that?
The Chinese competitor, CIMC-Enric. The sources show they are actively offering equipment at prices 20 to 30% lower than INOX.
Ah, yes. The price undercutting.
And India is a notoriously price-sensitive market. So my question is, at what point does a 30% discount overcome that established trust and certification shield?
That's a great question. CIMC-Enric definitely represents the most substantial threat to their domestic dominance. However, international procurement involves variables beyond just the sticker price.
Like what?
Well, the qualification and regulatory approval delays for imported cryogenic equipment are substantial. Domestic EPCs and Indian regulatory bodies are highly cautious.
Right.
Any equipment arriving from overseas must pass rigorous inspections by PISO.
PISO, what is that?
It's the Petroleum and Explosive Safety Organization of India.
Okay. So the friction of customs, import duties, and local safety audits really changes the calculus.
Completely. Even when factoring in a 21 to 25% residual import duty, Indian clients frequently select INOX based on delivery reliability and an established safety record.
Because delays are so costly.
Exactly. A 30% discount on paper evaporates entirely if the imported tank sits at a customs depot for weeks, fails a piso structural inspection, or delays the commissioning of a larger industrial plant.
Right, time is money in construction.
So the reliability of localized manufacturing and direct oversight currently offsets the aggressive pricing from international competitors. But it does require INX to maintain flawless delivery timelines and quality control.
Okay, so we have a clear view of the market dynamics here. We have a structurally growing demand curve and a heavily fortified competitive moat.
Yes.
Now we need to examine how this specialized engineering translates into the financial reality.
The numbers are pretty impressive.
They really are. The reporting shows revenue growth hovering consistently around 18 to 20%. The EBITDA margins run consistently at 22 to 24%, and the net profit margin sits right around 16.25%.
For a heavy manufacturing business, pulling down 24% operating margins is exceptional.
It's surprisingly high. And looking at their future revenue visibility, they are sitting on a substantial order backlog. As of the second quarter of their fiscal year 2026, the backlog expanded to 1,485 crore rupees.
Which is a very healthy pipeline.
Yeah. This provides clear visibility into their production pipeline for the next 9 to 15 months. But crucially, 63% of this backlog is entirely export-oriented.
Yeah, the export metric is a major shift in their profile. We'll definitely have to dig into that.
We will. And looking at the health of the balance sheet, they have maintained zero borrowings since March 2021.
Which is practically unheard of in this space.
Right. As of March 2025, they are in a net cash position, holding a surplus of roughly 294 crore rupees.
Operating a heavy industrial manufacturing company with zero debt and a cash surplus is highly unusual.
It is. This financial structure allows them to generate an exceptionally high return on capital employed, or ROCE, exceeding 35%.
It's very efficient.
And the sources point out that the management philosophy driving these numbers is deeply conservative regarding financial risk.
Oh, absolutely.
The promoter holding, so the shares retained by the founding and managing group, is notably high at 75%.
Which shows a lot of skin in the game.
It does. Their approach favors organic, self-funded growth over leveraged expansion. And there's a defining example of this discipline in the research. It involves a struggling U.S. subsidiary called CVA.
Ah, right, the CVA situation.
Yeah. Rather than injecting further capital to attempt a turnaround or masking the losses through an acquisition, the management simply chose to liquidate the entity.
Right, they just cut their losses, which is a very pragmatic move.
It is. The 75% promoter holding and the zero debt posture really reflect a management team that avoids financial engineering and focuses aggressively on the physical execution of their product lines.
Very grounded.
Yeah. And part of what protects those 22 to 24% margins is their revenue model, specifically how they handle raw material costs.
Yes, this is a key part of their strategy. They utilize what's known as a pass-through model.
How does that work here?
So raw materials, primarily stainless steel and those special nickel alloys we talked about, constitute 50 to 60% of their cost of goods sold.
That's a huge portion of their expenses.
It is. So if global commodity markets experience a spike in steel or nickel prices, INOX passes those increased costs directly through to the customer with a predetermined markup.
Oh, I see.
Yeah, the customer absorbs the volatility of the commodities market, and that shields INOX's operational margins.
So they aren't taking on that commodity risk.
Exactly. They are pricing their services based on their engineering expertise and fabrication labor rather than speculating on the direction of raw material costs.
That makes sense. And operational scale also plays a role here, right?
Mm-hmm.
The sources note that when their manufacturing plants, like the primary facility in Alalai, operate above 70% capacity, their profitability scales upward efficiently.
Yeah, because of the fixed costs.
Right.
Once the fixed costs, such as factory overhead, facility maintenance, and the salaries of the engineering teams, are covered by the baseline production volume, every additional unit manufactured contributes a higher percentage of profit directly to the bottom line.
Got it. Furthermore, for their large-scale turnkey export projects, they employ milestone billing.
Which is also crucial for cash flow.
Right. They receive payments as the project successfully reaches predetermined design, fabrication, and testing phases.
So they aren't waiting until the very end to get paid.
Exactly. This structure keeps capital flowing into the business consistently. It shortens their cash conversion cycle and funds ongoing operations without requiring external debt.
So the operational engine appears highly optimized. You have strong margins, zero debt, a 1,485 crore rupee backlog, and a heavily protected market position.
It looks pristine. But we need to look at what they are doing to secure growth into the 2030s and also analyze the potential risks that could disrupt this trajectory.
Let's start with the growth. On the growth front, they are actively expanding capacity to handle that massive backlog.
Right. They're committing roughly 80 crore rupees for a technological upgrade to the Ally plant.
Yep.
And they're also developing a new greenfield site in Vadodara. And this site is designed specifically for serial production.
Serial production.
Yeah, focusing on standardized, high-volume output to complement their bespoke engineering work.
Ah, okay. So making a lot more of the standard units.
Exactly. But they're also moving up the value chain with the commercialization of cryoscientific technology. The sources say they are slated to commercialize India's first indigenous MRI cryostat in 2026.
This is a significant technological pivot for them.
What exactly is an MRI cryostat?
Well, magnetic resonance imaging machines rely on very powerful superconducting magnets.
Okay.
For the magnet to achieve a superconducting state, which is where electrical resistance drops to zero, it must be cooled to roughly minus 269 degrees Celsius using liquid helium.
Wow, that is incredibly cold.
Yes, so the cryostat is the highly complex, vacuum-insulated vessel that safely houses both the liquid helium and the magnet while still allowing the imaging equipment to function.
Oh, wow.
Yeah. Currently, India imports this critical medical hardware. So by manufacturing an indigenous version, INOX is targeting a new domestic market opportunity.
And how big is that opportunity?
It's estimated at 200 to 350 crore rupees.
That's a substantial new revenue stream.
It is.
And their global export wins are also accelerating across diverse sectors. For instance, they recently secured a 945 crore rupee contract to supply thermal shields for the ITER fusion reactor in France.
Which we mentioned at the beginning. That's huge.
It is. Delivering hardware for a project attempting to replicate the power of the sun is arguably the highest level of scientific validation an engineering firm can achieve.
It's the ultimate resume builder.
Absolutely. And on the industrial side, they won a colossal order to manufacture 30,000 beverage kegs for a client in Germany.
So they are winning both the ultra-niche high-tech stuff and the high-volume standard stuff.
Right. Another major future vector the sources mention is liquid air energy storage, or LAEs.
LAEs, right. This technology is fascinating. It functions as a massive thermodynamic battery for renewable energy grids.
How does that work?
Well, when a wind or solar farm generates excess power during periods of low demand, that electricity is used to run industrial compressors.
Okay.
And they compress ambient air and cool it to minus 196 degrees Celsius until it liquefies.
So they literally turn air into a liquid.
Exactly. And then this liquid air is stored in vast cryogenic tanks built by INOX.
Ah, I see the connection now.
Then, when demand on the power grid peaks, the liquid air is pumped through a heat exchanger and exposed to ambient temperatures.
Let me guess, it boils rapidly.
Rapidly. It expands hundreds of times in volume, creating a high-pressure gas jet that spins a turbine to generate electricity.
Wow.
Yeah. It provides grid-scale storage without relying on rare earth metals like lithium or cobalt.
That is incredible. And INOX is partnering on these storage projects, which could represent roughly 935 crore rupees in inflows by 2030.
It's a huge potential market. But while the growth vectors are strong, the business does face structural risks.
Right. No company is immune to risks. The sources primarily highlight commodity swings, cyclicality, and valuation expectations.
Let's unpack those.
Okay, well, we discussed the pass-through model protecting their margins from raw material costs. So how do commodity swings still pose a risk?
It's a timing issue. Sudden and extreme volatility in the global prices of stainless steel and nickel-based alloys can still create friction.
How so?
Because while INOX passes the costs along, there can be a lag in the billing cycle that momentarily squeezes margins.
Oh, just waiting for the paperwork to catch up.
Right. But more significantly, if the final price tag of a huge turnkey project inflates by 20% due to an unforeseen spike in nickel prices, the end client might balk.
Say an LNG terminal developer.
Exactly. They might pause or defer the entire project to wait for commodity prices to cool down.
Which hurts the order book.
Exactly. And this ties into the cyclicality risk. The development of LNG infrastructure is highly capital intensive and heavily dependent on government policy and global energy
The
markets.
sources say we are observing this dynamic currently in Southeast Asia.
We are. Small-scale LNG infrastructure bids in nations like Malaysia and Indonesia are facing delays.
Why is that?
If the global energy transition encounters macroeconomic headwinds, or if the price of LNG spikes, making it less economically viable as a transition fuel, INOX's international order book could experience a contraction.
That makes sense. The final component of the bear case is the valuation reality.
Right, the market pricing.
Yeah, the market is pricing the stock at a premium, roughly 40 times earnings.
That's a high multiple.
It is. When a company is priced for absolute perfection, there is zero tolerance for operational missteps.
None.
If that 22 to 24% EBITDA margin contracts even slightly, or if there's a prolonged delay in converting the 1,485 crore rupee backlog into realized revenue due to, say, external supply chain issues.
The market's assessment of the company could adjust severely.
Exactly, it's a tightrope.
And the current strategy inherently involves trading a degree of safety for necessary growth, which brings us to the core tension of their export model.
The export model, let's talk about that.
By targeting 50 to 60% of their future revenue from international markets, they are stepping outside their fortified domestic moat.
Right, where they hold a 60% market share and face minimal local competition.
Exactly. They are leaving that safe harbor and entering the global arena to compete directly against entrenched titans like Chart Industries and Lind PLC.
So they're introducing new variables into their risk profile. Things like ocean freight volatility, geopolitical trade tariffs, and cutthroat international pricing dynamics.
They absolutely are. But to maintain an 18 to 20% annual growth rate, relying solely on the Indian market is just insufficient.
The domestic infrastructure is expanding rapidly, sure, but not fast enough to absorb their full production capacity goals.
Right. They must export. Their strategy relies on leveraging the lower manufacturing and labor costs of their Indian facilities, combined with their globally recognized safety certifications to win international bids against Western competitors.
It is a higher risk arena.
It is, but they are betting that their engineering execution is globally competitive, not just locally dominant.
It's a bold play, but they have the balance sheet to attempt it.
They do.
So the scope of what we have covered today is pretty vast. It really is. We covered a lot of ground.
We started by looking at 1-liter medical dewars for biological samples, and we scaled all the way up to 1.5 million-liter stationary LNG tanks and the thermal shields protecting a fusion reactor.
The range of their products is incredible.
INOX India has leveraged extreme engineering mastering the thermodynamics of vacuum insulation and the complex metallurgy required near absolute zero, alongside these stringent microscopic safety certifications.
Which is no small feat.
Right. And through this, they have built a debt-free, highly profitable operation that serves as the invisible backbone for India's green energy transition and space ambitions.
They took a highly complex, safety-critical niche of industrial manufacturing, and they optimized it into a predictable, high-margin business model.
And now they're expanding its physical footprint across the globe.
Exactly. So the relevance of this deep dive is, I think, quite clear for you listening. The next time you read a headline about a green hydrogen hub securing funding, or a new semiconductor fabrication plant breaking ground, or ISRO successfully launching a new payload, remember the underlying physical reality.
It all comes back to the hardware.
It does. The technology of the future is fundamentally dependent on the industrial hardware of the present. None of those breakthroughs happen without a company building the highly complex, vacuum-sealed thermal containment systems required to keep the fuel stable.
It really is a critical reminder to always investigate the underlying supply chains.
Absolutely.
Because the companies executing the most essential functions for the future economy are very often operating entirely under the radar.
I want to leave you with a final thought to consider before we go.
Okay, let's hear it.
As global capital races toward a decarbonized future, trillions of dollars are being poured into the generation of new types of energy.
Right, wind, solar, hydrogen.
Exactly. But the ultimate winners of this macroeconomic transition might not be the entities generating the power.
That's an interesting point.
The true leverage and the most durable value might actually belong to the highly specialized engineers who are tasked with safely storing and moving that energy.
Because whoever solves the infrastructure bottleneck ultimately commands the value of the entire system.
Precisely. The physical infrastructure is the gatekeeper of the transition.
It really is.
Thank you for joining us on this deep dive. Keep looking beneath the surface of the headlines, and remember that even the most advanced technologies rely on mastering the extreme cold. See you next time.